Meet the moon snail, a marine mollusk that lays jelly-like crescent-shaped egg masses on intertidal muddy sandflats. These guys are common in Smith's Lake and their eggs can be found all along the shore. But here's the question that got me scratching my head. Do egg masses larger in volume also have a higher density of eggs? In order to better understand the resource allocation in moon snail reproductive strategies, a topic which is poorly understood, I sought out to answer this question. Here's the thing. If those larger egg masses hold fewer eggs, it might mean our snails are going for quality over quantity, giving each egg more resources to boost survival. But if bigger masses are loaded with more eggs, then it's a different story. That would suggest a kind of snail supermom situation. Healthier females in top-notch condition can afford to make larger egg masses and pack them with more eggs, maximizing their reproductive output. To answer my research question, I followed these steps. Each morning, I walked along the shore of Smith's Lake collecting egg masses which were completely clear, unbroken, and had a smooth, uncompromised surface. In the video, I'm showing examples of eggs which I did not select for my experiment. These are all either too old, or they were broken, or the surface of the egg wasn't smooth. These are some examples of eggs that I did use for my experiment. The first step was to measure the volume of each egg mass by placing them in a beaker with 200 milliliters of water and recording the change in volume. I then took 3 2mm cross sections from each egg mass, 2 3 centimeters from either end, and 1 in the middle. 2 5 by 5 mm samples were then taken from each cross-section, 1 from the middle and 1 from the edge, as my experimentation of just cutting eggs open revealed an obvious difference in the number of eggs close to the surface versus the center. Eggs were counted for each sample under a macroscope and recorded in Excel. From my preliminary findings, bigger egg masses seem to have slightly lower egg density but still contain more eggs than smaller masses. This would indicate a condition-dependent scenario. But why does all this matter? Well, understanding the reproductive strategies of moon snails can give us clues about how resilient their populations are, especially in the face of environmental changes. If we know that reproduction is condition-dependent, it means moon snails might be sensitive to factors like food availability or habitat health, anything that could impact female fitness and in turn egg production. Adaptability like this might be a key advantage in unpredictable ecosystems like the intertidal zone, where shifting conditions only favor the most resilient. It's a subtle but impactful display of evolution's influence on survival strategies in even the most unassuming creatures.